Hello everyone, and welcome. In this session, we're going to prepare for your probability quiz. I'll explain the key concepts you need to know, give you examples that are similar to the quiz questions, and show you step-by-step how to solve them. Let's get started. Probability basics. Probability tells us how likely something is to happen. The formula is always probability equals the number of favorable outcomes divided by the total number of possible outcomes. For example, imagine rolling a single die. There are 6 sides, so there are 6 possible outcomes. If we want the probability of rolling a 5, there's only one favorable outcome. That means the probability is 1 over 6. Another example, if you spin a spinner divided into 4 equal sections, red, blue, green, and yellow, the probability of landing on red is 1 out of 4, or 25%. Rolling dice. When rolling 2 dice, the total number of outcomes is 6 times 6, which equals 36. Each outcome is equally likely. Here's an example. What is the probability of rolling a sum of 5? The pairs that add to 5 are 1 and 4, 2 and 3, 3 and 2, and 4 and 1. That's 4 favorable outcomes. Since there are 36 total possibilities, the probability is 4 over 36, which simplifies to 1 over 9. On the quiz, remember to carefully count all possible pairs that create the desired sum. Odds versus probability. Probability and odds are related, but they are not the same. Probability compares favorable outcomes to all outcomes. Odds compare favorable outcomes to unfavorable outcomes. For example, let's say you have a bag with 2 red marbles and 3 blue marbles. The probability of drawing a red marble is 2 out of 5. But the odds of drawing a red marble are 2 to 3 because there are 2 favorable outcomes and 3 unfavorable outcomes. A common mistake is mixing these up, so always check whether the question asks for probability or odds. Independent and dependent events. Independent events are events where the outcome of one does not affect the other. For example, flipping a coin and rolling a die are independent. The coin does not change the die. If we want the probability of flipping heads and rolling a 6, we multiply the 2 probabilities. 1/2 times 1/6 equals 1/12. Dependent events, on the other hand, are when one event changes the outcome of the other. For example, drawing cards without replacement. If you draw one card and don't put it back, the probabilities for the second draw have changed. Complementary probability. Sometimes it's easier to calculate the probability of something not happening. This is called the complement. The rule is, the probability of not A equals 1 minus the probability of A. For example, if the probability of raining tomorrow is 0.3, then the probability of not raining is 1 minus 0.3, which equals 0.7. Another example, if the probability of drawing a green marble is 0.45, then the probability of not green is 0.55. Counting principle. The fundamental counting principle tells us how to count the total number of outcomes. If one event can happen in A ways and another event can happen in B ways, then together they can happen in A times B ways. For example, if you have 3 shirts and 4 pairs of pants, you can make 3 times 4 equals 12 different outfits. Another example, if you flip a coin and roll a die, there are 2 possible outcomes for the coin and 6 for the die. Together, there are 12 possible outcomes. Conditional probability. Conditional probability asks, what is the probability of one event happening given that another event has already happened? The formula is pause. The probability of B given A equals the probability of A and B divided by the probability of A. For example, suppose you have a deck of cards. What is the probability that a card is a king, given that it's already known to be a face card? There are 12 face cards total, 4 kings, 4 queens, and 4 jacks. Since 4 of them are kings, the probability is 4 over 12, or 1/3. On your quiz, check carefully if the problem involves replacement or no replacement. Replacement makes events independent. No replacement makes them dependent. Union and intersection, A or B versus A and B. When we ask for the probability of A or B, we use the addition rule. The probability of A or B equals the probability of A plus the probability of B minus the probability of both A and B. For example, suppose in a class of 20 students, 10 are business majors, 8 are economics majors, and 3 are both. What is the probability that a randomly selected student is either business or economics? We calculate 10 over 20 plus 8 over 20 minus 3 over 20. That equals 15 over 20, or 3/4. Remember, A or B means we add, but we must subtract the overlap so we don't double count. Final tips. To succeed on the quiz, remember these 4 steps. Identify what type of probability problem it is. Write down the total number of possible outcomes first. Carefully count the favorable outcomes. Decide whether the events are independent, dependent, or overlapping. Practice a few problems using these steps, and you'll be ready for the quiz. Good luck!